Well, welcome everyone. Thank you for being here. My name is Zach Roberts. I'm a conservation coordinator here at Weber Basin. We are lucky to have Grant Cardon with us. Grant works for Utah State University. He's a soil science specialist.
Yeah, I'm extension soil specialist.
Awesome. And I've sat through a couple of presentations that Grant has given over the years, and so when we wanted to talk dirt, I knew just who to call. So
Not talk dirty, but
right.
yeah.
So I'm going to turn the time over to Grant, and if you have any questions, feel free to raise your hand and get those addressed.
Yeah, we'll make this somewhat interactive. Grab a handout when you come in, folks, and follow along a little bit there. Well, as Zach said, I'm the extension soil specialist. My kids call me the dirt doctor. So I don't bristle at the term dirt. Some of my colleagues do. They think it somehow diminishes this particular medium that we have at the surface of the earth. It's so important. But I like the term dirt because it's in you, it's on you. You get in with it, you work with it, right? I mean, I like getting dirty. I don't like getting soiled. There's a difference in those terms. So I like getting dirty, and so I don't mind that as we go along. I understand from Zach that a lot of you have at least a modicum of soils background or has had some kind of introduction to it. Is that true? Or we're going to, so we can do some basic stuff as we go along. So what we'll start off with is, what is soil? It's not just this inert material at the surface of the earth. There's all kinds of services that it provides to us. We're going to think about it mostly in terms of it being a medium for plant growth when we're going through this today. But it interfaces uniquely in the natural environment with all other facets of the environment. It interacts with the atmosphere, it interacts with the water, it cycles nutrients, it provides physical support for plants. We also use it as a construction material. There's all kinds of services that it provides for us. And I like to think of it as the foundation for life on this earth. People will challenge me on that and say, well, water really fits that place. But I defy you to live on water alone for very long. All the good stuff in water that makes water good for us, that dissolve minerals and those kinds of things, those all come from the soil over time as it interacts with the water. And that's really important. One of the other things I want to point out on this is that we think about it mostly as the weathered rock and organic matter, but I should include in this slide the fact that it is alive. It is a living, breathing tissue at the surface of the earth, full of life. If you're holding a palm full of soil from your garden in your hand, how many organisms are you holding? Any idea? A lot, right? That's the answer, a lot. 3 to 4 times as many organisms as there are people on the earth. How about that? So about 15, 20 billion organisms in a good fertile handful of soil. And that's everything from microscopic animals, little worms, bacteria, fungi, you name it, protozoa, and so forth. And all of those provide really important characteristic to this material in terms of it being an effective plant growth medium. So we can't dissociate, if we want it to function the way it's supposed to, we can't dissociate the living from the non-living fraction of the soil. And so tonight we're going to talk a lot about the importance of that organic matter in supporting the living side of the soil. Okay. So let's take a kind of a big step back and look at just bulk development of soils in the landscape. All soils are derived from some original parent material, be it the rock, washed in sediments, dune sands, and things like that begin to then accumulate at the surface of the earth, and they begin to interact with the natural environment with a number of soil forming factors. They interact with the climate, they interact, the parent material imparts some characteristics. Time works on it, topography works on it, and the living fraction of the soil begins to work on it as well. And as those all work together, we get changes from the original parent material. We'll talk about those changes. If we take any volume of that unconsolidated material, big shovel full of it, what we'll find out is fully half of it is pore space, void. And that can be filled to one extent or another with water or air as conditions change. But that becomes a huge reservoir for exchange of those important parts of a soil system. The gases that they move through and are cycling in and out, or water that we store there for later use by plants and animals in the system, what have you. The solid materials mostly are mineral that come from that original parent material, mixed in with a little bit of organic matter. This says 5%. That's an average across the continental U.S. How much do we get to enjoy, for the most part, in Utah natively? 1.5%, 2%. Okay, so we bring the average down. In the central Utah area, we might only get about 0.5% natively of organic matter accumulation. But organic, that small little fraction of organic matter makes a big difference in the function of our soils. As the material begins to interact with the environment, it develops as we go down in layers. We don't call them layers, we call them horizons. Layers would kind of denote kind of a well-defined boundary between them, and sometimes they don't. They finger into each other, they gradually change, and so forth. But the A horizon, what we typically call the topsoil, is that layer that interacts the most with the surrounding environment. So the most change that goes on in the soil happens up here at the surface. When we get organic matter accumulations, a lot of microbial activity, gas exchange and stuff like that, changes in the minerals themselves as they weather and what have you. And then there's other horizons of change. This might be areas where clay accumulates or salts accumulate or weathering takes place in material a little bit more than from the original parent. And then down deep in the soil, we'll get to what we call the original parent material, fairly undeveloped. But all of these other horizons below the topsoil, we lump into this big category of subsoil. But if we look at the topsoil versus the subsoil, there are some bulk properties that are consistently the same across all soils. Okay. Topsoil are typically higher in organic matter than the subsoil. Lower in salt content, at least around here, for especially where we have natural accumulating of salts in an arid environment. Higher in nutrient classes because we've got the cycling of the organic matter, the release of nutrients on weathering and those things. Down in the subsoils, these are typically lower in organic matter, much lower. In case of Utah, almost void of organic matter. Higher in clay, in lime, especially in our areas. Higher in salt content, typically higher in pH. So, not impossible to manage these kinds of properties in the subsoil, but much more desirable to have these properties functioning to our benefit in the surface. So what happens when we do this? We dig a lot of basins in this state. Is that big mound of soil that comes out of that hole more subsoil or topsoil? It's mostly subsoil. What do we do with it? We spread it around and then we pack it down for good measure. And then we give the homeowner in this new HOA 1 or 2 years to establish a landscape in that material. And so we kind of put them up behind the 8 ball a little bit, right? In terms of dealing with the material that doesn't have as desirable properties as the original topsoil. Now, there are things or more and more attention being given to that important aspect. And so they'll stockpile the topsoils and replace them back as best they can. And if you have anything to do with a managed landscape, new build, whether it be a home or a building or office or anything else, what you can do to encourage the protection of that topsoil and the return of it will greatly enhance the ability of that landscape to support plant growth. This is a great extension publication. If you have a need to spec out a particular topsoil material, you can go to this the guidelines document, topsoil quality guidelines, and it'll give you what the ideal, acceptable, unacceptable property would be of a material. And it kind of helps guide the choice and management of those. My predecessor, Rich Koenig, in this position, is the one who wrote that. So that's bulk development. We can go into lots of detail. You can take an entire class on soil genesis and morphology up at the university if you want to, and learn about how each landscape, landform, soil types and other things develop around the world. I just got done managing a grad student who did all of his soils work in Hawaii. He's from Hawaii. He wanted to do it in Hawaii on Maui. And so he was looking at soil development across the island. And it's really interesting to see the influence of the ash ball and other things on the development of the soils. It was really cool to be involved with soils that I've never been introduced before. We're going to take a closer step now and look at taking that mineral material at first and kind of dissecting it, looking at its properties. Okay? So the first thing we look at when it comes to a soil when we analyze it is its texture. The word texture connotes how something feels, right? It's kind of a tactile word. How does it feel? And that's the way it used to be measured in the old days, where they would actually take some soil, wet it up, and rub it in their fingers. The gritty stuff was sand. Smooth feel to it was the silt. Sticky was the clay. And they could tell then by the proportion of those sensible textural feels what the percent of the sand, silt, and clay would be in that soil, and begin to categorize its texture. But there's a couple of things I want you to know about these that go beyond just their size, okay? And you can see the relative size. Clays are really tiny, silts are in between, sands are much larger. The sand and the silt, though, are just smaller chips off the original block. So they're smaller and smaller pieces of the original parent material. So we would find the same minerals in the sand and silt fraction that we would have found in the original rock that it came from. So say it was granite, we would find a lot of quartz, feldspar, some of the iron-bearing minerals and things like that in the sand and silt fraction, just worn down to smaller pieces. So these are what we would call the primary minerals. They're the ones that were originally in the rock. Clay, on the other hand, really tiny, but these are new minerals. We call them secondary minerals. They develop in soils in place over time. As stuff dissolves out of parent material, the sand and silt, and recombines into new structures, new minerals. Okay? You've heard some of the names of these: illite, montmorillonite, kaolinite, smectite, those kinds of things. The ites that we talk about a lot of times are the clay minerals, vermiculite, and so forth. Okay, they develop in place in soils over time. So we're going to look at the characteristics of these. Sands and silts, typically spheroidal in shape or rounded and blocky. Clays, on the other hand, since they're new mineral crystals, are just like that, a little flake of a crystal. They're broader across than they are thick. So they impart a lot of surface area per unit mass of them or weight of them in soils, much more than the sands and the silts do. So let's take a look at that surface area. As these develop in place in soils, they are subjected to big swings in temperature and water content and things in the material. And as they try to form, sometimes the structure gets perturbed and things are missing in the lattice. What was, from basic chemistry, compounds like to be electrically balanced, right? So what do you know about water? H2O, right? That's the chemical structure. 2 hydrogens and an oxygen. Positive charges from the oxygen or the hydrogen, 2 of them, balancing the 2 negative charges of the oxygen. You have a nice happy molecule. It's electrically balanced. But when clays form, things go missing in their structure. And typically what is missing is a positively charged element. So when that happens, we're left with unsatisfied negative charge in that crystal structure. That's super important to the way these function in soils and clays. Because now I have like a little magnet surface in the soil that can attract oppositely charged things to its surface. Conveniently, a lot of the nutrient elements that we rely on, magnesium, calcium, copper, zinc, iron, and so forth, are positively charged when they're in soil solutions. And they can stick to the surface of the clay like little magnets, like refrigerator magnets, and held there for later use by plants and animals in the system. So nutrient retention is greatly enhanced with the presence of clay. Sands and silts, they don't have this reactive surface. They formed in the magma as it cooled slowly, and those crystals are very perfect. There's not a lot of missing things in their structure, so they don't have a lot of surface charge. Where the clays have a huge amount of surface charge and a lot of surface area, so they contribute a lot to nutrient retention. We look at water. Water is a happy molecule. It's electrically balanced, but the hydrogens tend to stay on one side of the molecule. They don't visit the other side of the tracks very often. So we have this partial positive charge on one end from the hydrogen and a partial negative charge on the other end from the oxygen. You've heard of water as being the universal solvent, right? Everybody talks about it being a solvent. Water over time will dissolve anything. Well, why? If it didn't have this, what we call a dipolar character, it wouldn't do that at all. It would be just inert. It wouldn't cause any kind of dissolution of anything. But the fact that it's got a little positive charge on one side, a little negative charge on the other, it can surround a solid and begin to pull on the material electrostatically and weaken the bonds inside that material and slowly pull them apart. Okay, but that's why water has character. It can even dissolve the toughest rock, right, over time as it drips on it over a period of time. So water has that character. Well, that's really important because now water can also stick to the surface of the clay and held there from being just pulled through the material from gravity. Okay, so water retention is also greatly enhanced with the presence of clay materials in our soil. So clay is really important to the overall function of our soils as good plant growth media. Now, how many of you have too much clay? Okay, you can have too much of a good thing. All right. If we look at the properties of the soil with increasing clay content, we go from sands to clays. We get an increase over a certain range of clay in the plant available water that can be stored in that soil because of that water retention effect that we're talking about. But after a certain point, the soil holds more water, but it holds onto it so tightly that it's hard for the plants to pull it out. So there's got to be some sand and silt in the mix. You have bigger pores, less reactive surface area, things like that, to get the most optimal water availability. So at a certain point, we get kind of a reduction in that. Aeration potential, the more clay we get, goes down. Why? Because the pores get smaller and smaller and smaller as there's more and more clay. It's difficult for the air to exchange through those small pores. Drainage, the same problem with water infiltration and things, and then the compaction potential goes up the more clay that we have. If we look at any given spot, this is what we call a textural triangle. There's percent sand on the bottom, percent clay on the left, percent silt on the other side. Depending on the percentage of those size particles, we end up in one of these categories of texture. We give them names, okay? we soil scientists have nothing better to do but to name things. So here we've got clay loams, sandy loams, and so forth. It'd be nice if we all lived in Loamville, right? Loams are those soils that have really a nice optimal mix of sand, silt, and clay. Big pores, small pores, non-reactive and reactive surface area. They have a lot of really attractive properties. But all of the surrounding names include loam in their name. They have loamy type properties, which are really great for growing plants. But you'll notice we get past a certain level of clay in the soil and everything acts like a clay, right? It overwhelms the properties of it after a certain point. So about 35% or so clay, we start to have some of this reduction in the desirable properties of that material. So I will look at, I will always measure soil texture first on a sample, because I'm going to know right from that texture what the range of things like water infiltration, water storage, ease of utility, the amount of aeration, the native soil fertility, and those kinds of things are going to be with that material. That's why texture is so important. Now, what if I find myself in one of these extremes? If I'm way out on the sandy end or the silt end or in the big clay area on that. If I have too much sand, I say at least you're lucky there. You can get water into and out of that material, and you can manage the irrigation and other things appropriately to get the water that's needed for the plants that are there. You can select drought tolerant plants, and you can do some things to adjust the water retention. Talk about it for a minute. If I got too much clay, I'm kind of always in an uphill battle. Number one, it's hard for me to get air and water into that system to help improve the properties. And plants that grow well in poor drainage or lack of oxygen, we have a very limited number of them. So in both cases, in either extreme, I want to try to reduce soil structure. And that's where organic matter comes into play in the development of the soil. So we're going to talk about integrated properties now. The mineral material with that little bit of organic matter, even though it's small in some cases, how important it really is. Because when we start talking about the interaction of the mineral fraction, the sand, silt, and clay, with the organic material, then we get the development of what we call aggregates. They're secondary particles in a soil. Don't denigrate them by calling them clods. These are not clods. I can make clods just by mashing stuff together, right? These actually develop in soils over time as the organic matter begins to bridge these particles together in groups. Organic matter, like clay, has a lot of surface charge, so it can attach itself to things. It has water retention properties, it has nutrient retention properties, and it also has stored nutrients in its structure. So as it decomposes, it releases those nutrients as well over time. But we know that these aren't clods because we can look at a soil that's got this structure development, and we can see these intimate interactions microscopically with the organic matter and the mineral fraction. And as they form, they begin to pull apart in these aggregate units. And they open up much larger pores between those aggregates than were ever between the mineral particles, sand, silt, and clay. We call these macropores, and we greatly enhance the ability of air and water to move in and out of that system. Even if I have high clay, we get good aggregate formation and opening that up. You can see that in a soil that's got that good structural formation. Depending on the kind of clay and other minerals, we may get clayey structure or granular structure. Most of us in our neck of the woods, if you go out under your turf in the front yard and dig up a little bit of that surface soil, you'll see this granular structure right below the turf in the upper part of the topsoil. You can take a handful of that and gently bounce it in your hand or in a box top or something like that, and you'll see it break into these little granular structural units. Okay. That's indicative of really good soil formation. And that's what happens when organic matter functions properly in a soil system. So if I've got a poor drainage condition, a lot of clay in that situation, I add organic matter to improve structure. Then I take care on how much water and when I put it on, and I do it lower rates, longer times, less frequency in order to get the soaking that's needed in those. And I might be so high in clay, I want to just abandon the use of it in the first place and go with a raised bed or something else where I bring in a material that has better properties. But most of the time, I can improve any really high clay content soil, unless it's too high, with the addition of organic matter and doing what I can to promote and protect structure, the formation of structure in that system. In a high drainage condition, lots of sand, by adding organic matter, again, I improve water retention because I've got those reactive surfaces on the organic matter, and I form aggregates, and then I can be careful about water management as well. So I get benefits from the addition of organic matter, regardless of what soil I put in. It is the single best soil method ever. Okay. You can add all kinds of other chemical things and so forth, but organic matter is really where it's at. And we'll talk about what I mean when I say organic matter and what types have the best effect on soil structure as we go on. Okay. But I can improve drainage in high clay soils. I can improve water holding capacity on sandy soils. I reduce the potential of compaction to form those aggregates. They don't get packed in as closely anymore. Provide nutrients. The organic matter breaks down in cycles as well. Improve the tilt and what have you. Okay. So we already talked about how much we have in Utah. I would like far more. We all would in our soils. I was just on sabbatical. Telling Zach, I was on sabbatical last year in the Midwest. They got sands out there that are 6-8% organic matter. It's unbelievable. You know, they support that much plant growth. They can accumulate that kind of organic matter over time in the soil. It's amazing. So whatever we can do, we would like to have more here. So where we can add it, we want to do it, and we want to do it regularly. What is organic matter? Remember, we've got a living part of our soil. What is organic matter to the living fraction? Food, right? It's a carbon source. It's going to be continually breaking down. If we don't put new organic matter into the system, then we're on a downhill trajectory with respect to organic matter in our soils. We're on a downhill trajectory with the maintenance of soil structure. All kinds of things can really degrade very rapidly if we're not replenishing the organic matter in the system. So, how much? And then we'll get into the types in a little bit. How much? On a turf area, if you're managing turf, you can't really till it in, right? We can really just put it on the surface, or we can use an aerator or whatnot to help get it down below the surface a little bit. But typically a quarter to a half an inch on turf, breaking that down in to get it down to the soil surface so it can begin to decompose and incorporate. Where we have annual areas where we can mix it in, at least an inch on the surface, tilled in or mixed in, is a maintenance amount for this area. We'll burn up that much in decomposition over time if we're not replenishing. Okay? 2 to 3 inches if I'm trying to kickstart a new turf area or a new flower bed or something else. Low salt material without the weed seed and things like that in it, then that's even better. One of the documents way back in extension history here at Utah State recommended 6 to 8 inches of organic matter mixed into annual growing areas where I can mix it in. If you want to get that much, great. If you can handle it, great. 2 to 3 inches, though, gives you that boost. It gives you the maintenance amount plus a little extra to help maintain. 1 inch of material on the surface of 1,000 square feet is about 3 cubic yards of material. That gives you kind of a rough idea of how much would be needed. there's all kinds of different sources. All of them, being organic matter, will impart those properties I'm talking about, the soil structure development and things like that. But we've got to watch out for some of the different categories. Woody residues are really, really high in carbon versus their nitrogen content. When that happens, the microbes that are breaking it down need nitrogen to do that work. Where are they going to get it if they can't get it from what they're chewing on? They're going to get it from the soil around them, right? So they're going to incorporate all the available nitrogen they can from the surroundings into their bodies while they decompose the woody material you just introduced. And that robs it away from the growing plants in the system. Okay, it'll immobilize, that's what we call it. It mobilizes the nitrogen for a time. If I put a woody residue into the soil, it'll take about 6 to 8 weeks before I get a rebound in the soil nitrogen content. Okay. So if you do put a woody residue, what am I talking about? Sawdust, mill waste, and those kinds of things, and mix that into the soil. I want to also put some extra nitrogen in the system to help prevent that immobilization. So the microbes can break it down, and it continues. It can provide the building blocks for soil structure as it decomposes. If people worry about this when they talk about putting decorative mulches on the surface, like bark mulches and things like that, unless you're incorporating it into the soil, you're not going to get that immobilization. Stuff that's sitting on the surface doesn't cause that. It's only when it's mixed in and the microbes are trying to break it. Grass and leafy greens, they have a very low carbon to nitrogen ratio, and so you can incorporate those readily without causing that immobilization. Compost, that's why we compost the materials, is to narrow that carbon to nitrogen ratio to, we get rid of some of the carbon dioxide, we get a more narrow ratio so that when you do incorporate it into the soil, it breaks down effectively without causing immobilization. But all of these will give us the intermediate decomposition products that are responsible for helping create those aggregates. The gelatin, denatured proteins, and other things that are the sticky stuff, part of the decomposition of these materials that helps hold those aggregates together and form them in soils. People ask me a lot at this point about what about humic materials? What about humic acid, fulvic acid, humate? Humic acid, fulvic acid, and humates are what's left over after all decomposition has happened. Okay, they are organic matter, but they are not readily broken down any further in the soil. So when I incorporate them, I'm incorporating organic matter, and I'll give some enhancement to nutrient retention and water retention sometimes if I add enough. But they're not going to break down. They're not going to feed the microbes, and they're not going to provide the building blocks of soil structure. Okay. I want raw materials or raw herb materials that are going to give me those intermediate breakdown products that are going to be really sticky and help hold aggregates together and feed the microbes. Most of the time in those humates, when they say it'll feed the microbes, they've added a readily decomposable carbon source with them, like a sugar or something else in them, and then we can see the rise in the response of the microbes. That's very short-lived. Human materials. So, how do we get it in the soil? Growing plants is actually the best way, one of the best ways to get organic matter into the soil. That's how those prairie soils develop, those big, deep, dark topsoils with lots of organic matter in them. They just have a lot of plant growth that environment, higher humidity environment, things like that can support. And you had the root material that explored that soil far better than you can mix it in. And the blooming and waning of roots over time, the return of leaf litter and things like that, it's going to really build organic matter over time. We can mulch around perennials and let organisms incorporate that organic matter down at depth. Ants, beetles, worms, and other things will take that material down 10 inches to a foot or more into the profile. Ants are really at doing this. Many of our ant species will actually get the organic matter. There are primary terrors of harvest of organic materials. And they like to actually, some of them will take it down into their dens and they'll cultivate fungus on it that they eat. They eat the fungus on the breakdown of the organic matter. Yep.
How long does that take to have?
Not very long.
One season?
Yeah, that'll happen in the incorporation of the season. So you can actually see over time the change in organic matter content with the action of these soil organisms, okay? Earthworms and ants and beetles. How many ants do we have in our environment? Here's a party starter question. In temperate environments, ant bodies account for fully 10% of the total biomass of our system. Okay? So if you take all humans, all animals, all insects, all plants together, and you combine all of that organic material, ants are 10% of that total. In a tropical environment, it's 20% of that mass. People worry about, an anthill forming in the middle of their yard and spray it. Yeah, you know what you've done? You've mildly annoyed it and they've gone 10 feet to the left. There are so many ants in our system, in our soil system, and they do a lot of this breakdown, at least the initial breakdown. They're part of cultivate fungus addition to decompose stuff. So, some guiding principles on organic. Like I said, addition to organic matter is the single most effective soil amendment that you can provide, because it not only provides all of these services in terms of feeding the living fraction and things like that, but it provides those building blocks, aggregate formation, and stability over time. We almost never get enough, especially in our arid areas, so we want to put more and more in if we can. It takes a while to do this. This isn't an overnight solution. It takes about 4.5 years in our environment to get optimal soil structure development under an undisturbed condition, okay? But we're disturbing a lot, right? In our gardens and other things, we're tilling and we're mixing and things like that. We need to minimize that so we don't break down the structure, but it takes a while. You're not going to see an immediate change. But you're going to see a steady change as you continually replenish organic matter in the system.
You said earlier about having compost or manure or something to be careful for salts. How do you do that? How do you know?
How do you know
it's salt?
Most linear providers now are getting it analyzed for. So like our layer composts, the compost at the landfill, other places you can find it will provide some kind of analysis. If not, you can send it to the USU lab and they'll analyze it and tell you. If you buy one and you use it and you're not sure, get it tested and then you can do additional remediation, like pushing water through it to leach the salts out. If it's been well composted and the compost has got up to at least 140 degrees for as little as 2 hours, it'll denature the weed seed. Okay, so it doesn't take much to denature the weed seed. It may still have a lot of residual salt in it. The reason being, we're using manure. Sidebar. When I first got here in 2005, I was an undergrad at Utah State a long time ago. I was at Colorado State for 14 years before I came back here. When I first got back, I sent a message out to all the county agents. I said, find as many different kinds of poop as you can find and send it to, not human, animal stuff, okay? Manures and compost. And we're going to analyze them for salt content, nutrient content, and so forth, kind of break down the properties. The saltiest stuff comes from the animals that we intensely manage, the layers. Why? The poultry manures tend to be the highest in salt because we drive mineral content in their diet to build strong and uniform egg shell formation, okay, in those. We want good eggshell formation. So there's a lot of mineral that goes into the diet, and the waste mineral comes out in the waste stream. So you get that salt content that builds up in poultry. The next highest is dairy manure. Again, we get a lot of mineral and there's a lot of urine that gets mixed in, and so those are higher. Steer manure, the notch down below, and then you get a big drop in salt content to horse manure. Horse is actually really good. It doesn't have a lot of salt in it, but the very best that we found for low salt, high nitrogen or nutrient content were goat and sheep manures. Okay, rabbit was kind of in that same realm there, but goat manure was by far the very best. It just had a really good mix of things. But regardless of what's there, you can leach that material if it's been well composted. Like the poultry manure, which we are all really quite familiar with, is Nutrimulch. That comes from the turkey industry over in Sanpete County. They've done a really good job of composting, leaching that material, so there's not a lot of residual salt. So you can leach it out. You can put extra water through it if you discovered you put one that's too high. Okay. The problem in our soils is that if we don't put additional organic matter in, or we disturb it too heavily, we can break down soil structure in a very short amount of time. So the half-life of loss of structure is only a few months, where the half-life of building the structure is years. So you can see that we're kind of on a precipice sometimes with the way we manage organic matter. So my recommendation is you get it in, but you don't till too much. You don't do things that are going to disturb the aggregates that are there, at least to minimize that as much as you possibly can, and get your organic matter back and replenish.
Does that mean not till it?
If you're going to till it, do it purposefully. Get something mixed into it. We're not interested in making a powder, okay, for seed beds and things like that. So don't over till it, and don't till it when it's too wet or too dry. And how do you know? If you're getting a full bite and the soil is breaking up rather easily with a tiller, then it's at a good consistency. If I'm just bouncing on top and I'm not getting a good bite, that's typically because it's too dry. And what am I doing? I'm putting pressure, which is compacting things, and I'm powdering the surface, just breaking up aggregates. If it's too wet, I'm getting a big bite, but it's not breaking up these things, staying in large clods. Those are clods, big chunks. Okay. What's happening is at the bottom of the bite of the tiller, you're smearing aggregates. It's too wet. You're smearing the aggregates and you're forming a compaction layer just below the surface of the soil where you're getting that bite to go. How do I know? I've done it when it was too wet because I'm antsy to get in Logan weekend. As soon as the snow clears, I want to get out there. But sometimes it's too wet, and I'll get out there and I'll mix my organic materials in, or I'll turn what cover crop I've got or whatever down under so it can begin to decompose. And I had one year these beautiful tomatillos. They were huge, they were full of fruit, and a little light wind came through and they all blew down. And I thought, I got some kind of root fungus going on. It's damaged the root system or something. I pulled them up. No, the roots were fine, but they had just grown down to my little tillage pan and they hadn't grown any deeper. And so they didn't really have enough depth of root to keep the top from toppling over. And I had to kind of do some work to address it.
Question.
Yeah.
So is it not okay on the opposite end, not till at all and just throw the organic matter on the plant and that can cause the same?
It just takes a lot longer for it to get down below the surface and really develop the aggregates. So in a situation like that, if you want to minimize your tillage, don't use mechanical tillage. Do it by hand, a spade or a fork or something else where you can
And just
turn it and let it lightly turn. And the aggregates will break apart naturally if you do that from each other without smashing the aggregate altogether. How many of you seen these little mantis tillers? I call them soil blenders, the little tiny things that people cultivate with. Wow, they powder, they obliterate aggregates. Okay, so if you're going to use those, do it really quick, and you're only like maybe cultivating between rows really quickly to kind of knock down a weed or something like that. But I tend to recommend them just because they're aggregate destroyers. Okay. What time we got? We got a few minutes to cover compost. We're perfect. I might be perfect. How about you? All right. Composting. So we've been talking about all this organic matter. You can create the perfect organic matter by doing composting. How many of you do compost? Zach, okay, one or two of you. This is probably the most underutilized resource we have available to us. We bag up and ship off a lot of organic material from our yards, from our gardens and other things, which we can use to advantage. Now we know how important that organic matter is. Let's try to use it to our advantage. So what are we trying to do in the process? We're trying to create a well-balanced food for the microbes that are going to do the decomposition of that material to kind of bring that carbon to nitrogen ratio down to a really good level that we can incorporate then that material without causing nutrient mobilization. So we mix green materials, which are high in nitrogen. We call them green. They may not be the color green, but oftentimes they are. And brown materials that are high in carbon. Microbes need carbon and nitrogen. I would love to just eat it in and out all the time, but that's, you know, a very monotonic diet, right? It's not going to be broad enough to give me all the nutrients that I need. So we got to do the same in the compost pile. We'll talk about what falls into those different categories here. We put it all together and we create conditions that are going to be beneficial to the microbes so they can decompose that material. And if you're doing it right, it's well aerated, it's well watered, it's got a good mix of brown and green materials, then really the primary decomposition products are carbon dioxide, odorless gas, water vapor, and the creation of heat. This is an oxidation process. They are literally burning that material, but really, really slowly. Okay. So we get water vapor, heat, and carbon dioxide. The carbon dioxide loss is what helps to narrow that carbon to nitrogen ratio within the mix. And then we get a finished product we can use where we're going to get additional breakdown. It's going to feed the microbes and it's going to create the building blocks for soil structure development. So let's look at the brown and green materials. So the brown materials, mature dry grass. If you cut the grass and you leave it in a big pile and it turns brown and kind of dries up in the pile before you put it in the compost, we'll consider that a brown material because most of the nitrogen has volatilized back off into the atmosphere. A lot of the nitrogen is gone. Woody materials, we already talked about how high they can be, 200, 300, 400 to 1, depending on the kind of woody material that you've got. A note on woody material, there are a couple of different woods that we don't want to put into a compost pile. Black walnut and cedar. Cedar, we encountered quite a bit because if you've got a rabbit hutch or an animal hutch or something else, a lot of times you're using cedar shavings as the bedding. Cedar has a natural biocidal property. That's why we make cedar sheds out of it, right? Keeps fungal growth and insects out of it and things like that. It has a natural biocidal property. We don't want to suppress the growth of the microbes by putting that in. Black walnut has a plant toxic chemical in it, and it doesn't break down very fast. It can take 2 to 3 years to break down completely. And if I put that material in, it will suppress the growth of the plants that are then growing in my garden or my flower. So black walnut and cedar we try to avoid entirely. Bark, stalk, stems, those kinds of things. The stems from woodier materials like your corn stalk, those kinds of things. Those will be classified for gardens. Paper products, not coated or treated paper, but if you still get a newspaper, newsprint's fantastic. The problem with newsprint is you put it in the compost pile and it tends to mat. It's not got a lot of surface area for attack and it tends to mat and causes issues. You don't want that because then you can't get air in between to get that microbes to work. So what I'll do is I'll stick it in a bucket, a 5-gallon bucket. I'll just soak it. I'll keep throwing the papers until I get several in there. And then I'll use one of those drill attachments for paint stirring and just whip that up into a frothy pulp. Okay, and that just breaks it apart to the point where then I can mix it in really thoroughly with the compost material. Coated papers and those that have fluorescent coloring inks on them. The coated papers have treatments that prevent breakdown. That's why they're coated. We want to use them in books and archives and things like that. What's that? Catalogs and things. We don't want them to break down, so we've got these coated papers. The fluorescent inks tend to have heavy metals in copper, nickel, other things, and we don't want that either. So if it's got fluorescent inks or coating, we don't want them. The green materials, fresh grass clippings, your plant-based kitchen residuals. Don't put animal fats in your compost pile. Animal fats are fine. They'll break down just like any other organic material, but they're really smelly when they do. They produce a lot of hydrogen sulfide and methane gas when they break down. Very, very smelly. Your neighbors won't appreciate you. Your wife won't appreciate you. Mine doesn't. And it'll attract unwanted guests to your compost. Bats and rats and snakes and other things that are looking for those animal fats. So you want to say your cull vegetables. I make a joke that compost pile is a great place to get rid of unwanted zucchini. You know, you got too much, grows too big because you're gone over the weekend. You come back, it's a great addition to the compost. Cut it up, break it up, so that you get a good surface area for a time. Most manures, except for meat-eating animal manures, okay, dog, cat, scat, things like that. You don't want to put in there again because the animal fats are the process there. Waste fruits and vegetables. People ask me about coffee grounds all the time. Coffee grounds are terrific. You can actually use coffee grounds directly as a fertilizer. They got about 2 to 3% nitrogen in them, and they're just a really low analysis fertilizer. And I don't drink coffee, but I love the smell of it, and it's kind of like aromatherapy. Perks your plants up in the morning. People ask me about eggshells all the time. If you're east of the Mississippi, eggshells will dissolve. If you're not, they won't. They'll just break into. They're not organic. They're produced by an organic machine, right? Chicken, but they are not organic. They are mineral. And so they're calcium carbonate. We have copious quantities of calcium carbonate or lime in our soils already. It won't break down. It just breaks in smaller pieces, but it doesn't provide any organic material. And we don't need additional calcium carbonate in our soils. You can put them in, it won't cause a problem, but they don't. So that's kind of a nutshell grouping of these. So what do we want? We want a nice, we've already talked about don't put these products, very products. Don't put things in it that aren't going to decompose over your life. Okay. Equal parts. We want equal parts of brown and green materials. Don't go and buy a special scale or anything like that. You can tell. Okay. You want to put about equal parts by weight of these materials, and you want to mix them thoroughly in the compost, or you want to layer them. How many of you heard of lasagna gardening or those kinds of things? Well, what are they doing? They're putting a layer of brown material, a layer of green material, a layer of brown material, a layer of green material. So they're actively composting and they're using it as the growth medium at the same time. Okay? That's all they're really doing. And they just continue to add additional layers and alternating layers over time as that stuff breaks down.
Can I ask you a question?
Yeah.
Like in the middle of the summer, you're mowing your lawn, you're producing a lot of green
Right.
compost at that point. And you don't have a lot of browns to do your layer or your.
So what do you do in that case? And that happens.
Yeah.
That's where newspaper the newsprint comes in, I can keep some of that aside and I can mix that in with those new grass clippings.
Or keep your.
What's that?
Fall leaves.
Fall leaves, if you've got a big pile of them, that works too. The other thing I've found really effective, a nice bale of straw, wheat straw. Just have it on hand and I'll run it through an old lawnmower to break it up really fine and I'll mix that in. Or not cedar shavings, but if you go get a pressed bale of pine shavings at the pet store, or IFA or whatever that's bedding material, those pine shavings will work really, really well too. And it smells really good when you mix that fresh pine shavings in with those really green materials. So it doesn't take much to help mix that up. You can also increase how frequently you turn the pile. We'll talk about that here. If you get too much of green material in it, you can turn it much more often to re-aerate it, and that's the issue with the green material. So we want to add water to the consistency of a wrung out sponge. We want these fairly wet. If you try to build the pile and then wet it up, it will not wet. Organic matter sheds the water. It'll be very, very difficult to get it down into the middle of the pile, especially since you want a pile at least 3 by 3 by 3 foot. Okay, if it's outside. If it's contained in a container, you can get away with a smaller amount. But in a pile outside, 3 by 3 by 3 provides enough mass to insulate it from heat loss so that the internal parts of the pile can get up to around 140 degrees Fahrenheit. We want them to get up that high, that hot. How hot is that? Most of our hot water heaters are set to about that level. So, you know, you can't put your hand under the straight hot water for very long. It's pretty doggone hot. I tell my kids when they were younger, if you get locked out of the house in the middle of the winter, go around back, open up the compost pile, sit in it until we get home. Because it's nice and toasty warm in the middle of that all winter long. It'll stay right around 100 degrees. It won't get up to 140 because it's too cold.
Did it ever happen?
Yeah, what's that?
Did it ever happen?
No. They gave me a bad time about it. But I always made them go out with me in the middle of the winter and drive their arm deep into the pile and they could feel that warmth. So they knew I was just joshing. And you want to turn it quickly. The turning is aerating the pile. Those microbes need oxygen. If we don't have oxygen in the pile, what's going to happen? Rather than carbon dioxide coming off as the gas, it goes anaerobic, and then we get hydrogen sulfide and methane and other gases that come off of it, and they're really, really smelly. And it slows the decomposition way, way down. Because the decomposition is really an oxidative process. It needs oxygen to really progress well. And so if you get a lot of green material in there, you think maybe I don't have a good balance, just turn it more often. In that case, that would be like a weekly turn if you had too much. I get away with mine 2 to 3 weeks at a time before I turn it, and it processes just fine. Siding your compost. Don't put it underneath your neighbor's window because it will produce odors. My wife can tell when it needs to be turned. I can't very often, but she can tell the second it goes anaerobic. You need to go turn the compost. If it really is a bad use, yeah, it's getting bad. She asked me actually not too long ago, if you die before me, do I have to keep composting? I said, no, it's my thing. You know, you don't have to worry about anything. I set a sunny location for winter composting. If you're north of Cedar City, forget it. You're not going to get enough warmth to really do active winter composting. So that's when I talked to Washington and Kane County and other places in the south end of the state that they can do that. Close to a water source, you can wet these up. As you mix them and turn them, you want to be putting water in and mixing in the water as you go, not trying to wet the whole pile at once from the outside. And then in a semi-permanent location. Now, there's all kinds of different compounding you can do. This is overkill, where you have fresh material and you rotate it into an intermediate and a final kind of finish area. You can do that if you want. I like this method, and this is the way I've done it. I've got a 4x4 foot frame, chicken wire. It's open on the bottom. I've got a third of an acre. I've got 2 honey locust trees, about 4 cottonwood trees along the front, green ash on the other side of the front yard, and then all my lawn clippings and all my garden waste. And I can handle it in a 4x4 if I break it up enough. And I'm putting it in, I'm mixing it in, I'm taking the stuff out regularly that's pretty well decomposed. Okay. So I'll put it in here. I'll mix it in, I'll wet it up, and then I'll turn it. When I turn it, it's hard to dig into this thing down to the depth. It's open at the bottom. I just push it over, okay? And I turn it over and I set it next to it at the pile. And then I just pitchfork the material into the new location. When it's ready to turn, I go back the other way. So I just alternate between 2 spots in the backyard. And I used to have handles on it all the way around. Me and my 3 boys would go out and we just lift it off and put it down. Now I can't do that. So I just push it over and move the turning. People will put eyelets on them, open them up, they're hinged. You can do that. A cylinder of 1/4-inch metal mesh, fencing mesh. You can make a nice 3-foot cylinder or bigger, and then zip tie it together with cable ties. When you're ready to turn it, clip the zip ties, open it up, put it next to the pile, zip it back up again, pitchfork the material back in and mix it up. Get it wet again, put new brown and green materials in as you have them. And what you're going to find is if you do this, you're going to be left with a pile down here at the bottom that's typically really well decomposed that I can't scoop up readily with a pitchfork anymore. And I just take that material out, I'll stockpile it in the corner of the garden, I'll use it in my wife's pots. I'll spread it around in the flower beds for additional organic materials and surface mulch, and then I'll work it out later. So you can constantly be taking stuff out of this as you continually turn it. And that's why I can keep capacity over the course of the season with this. You can do other things. This is ugly as sin, but he's actively composting in the pile around this, all these old bathtubs, and he's made them into a little hoop house where he grows his starts in the finished compost, and then puts the starts out in the garden and composts them and collecting stuff. Not particularly attractive, but it's functional. You can buy pre-made structures. Problem with these, a lot of times, is it's hard to get enough aeration into them. They're enclosed. They go anaerobic a little bit faster than an open pile does. You can open up these slats to let more oxygen in. How many of you seen the ones like at Costco or Sam's Club? They look like a lottery ball, a spinner. Yeah, those work great too. But again, they're enclosed. You got to turn them pretty frequently. They don't handle that much material, but you don't maybe need that much as you go. So when is it done? If it doesn't smell bad, I love the smell of really well cured aerobic compost. It has that really deep, rich, earthy smell you get from the actinomycetes and other organisms that are breaking in that. It smells wonderful. If it doesn't look like last year's tomato vine, it's indistinguishable, it's broken down well enough, it's probably pretty close. If it doesn't keep, if I've got everything, I've got the mix right, I've got it turned, it's aerated, I've got good water content, and it doesn't get up to 140 degrees, maybe 100 or something like that, then you know that the real active breakdown is pretty much done. Yeah, you can put that in the soil without causing issues. And sometimes there's the expediency factor. It's time to put it in the garden. I need to put it in the garden. It may not be completely decomposed yet. If that happens, as with a woody material where I may have too wide carbon to nitrogen gap, I can add a little extra nitrogen with it to help keep it from causing immobilization in the soil, and then it'll continue to break down. So with those in mind, I would encourage you to try to use your homegrown resources to provide the organic matter that you need, because it's going to be way better than you can get compost from the landfill or from any other source, even from a well-composted manure. things that you can buy. You know where it came from. You know what's in it. You know how good it is. And things like that. One of the things I do recommend is that you don't use somebody else's grass clippings. Because you don't know what they put on their lawn, right? You don't know the chemicals and things like that can carry over. Be mindful of that because some of these chemicals, herbicides and things like that, have very long half-lives of breakdown. Most of the ones, Roundup is denatured pretty quickly when it comes in contact with soil materials. Dicamba, which is one of the big ones, 2,4-D, those break down pretty quickly. But some of the other ones, the longer term ones, the things that we would use to keep a gravel driveway free of weeds and things like that, those can get on neighboring areas and they can last more than a year without breaking down in many cases. So watch out for that. And you don't really know what's going on with that kind of chemical use around you. So I would stick to what you know. Whew, there we go. We did that in an hour, Zach. How about that?